So, see, dimensional equation has got many uses. Like first use is here checking the accuracy of the given equation, given formula, and second one is here conversion of one system of unit into another system of unit, and third one is the derivation of formula. So, first I am taking here the checking of accuracy of the given relation. So, first one is checking of accuracy of given relation. If you have got a given relation, now you can check whether it is correct or wrong. For example, you are taking V is equal to U plus AT. That is the relation between speed and time, where A remains constant here. So, now if you take here the left hand side, here the V, its dimensional formula can be written m raised to power 0 L t raised to power minus 1, that is the dimensional formula of speed. If you take right hand side, you can write dimensional formula of this. So, here m0 L t raised to power minus 1, because u is initial speed and v is final speed. So, that they will have same dimensional formula, plus a can be written m raised to power 0 L t raised to power minus 2, and t can be written just t. If you solve this, this is a power 1 and power minus 2, you will be getting m 0 L t raised to power minus 1. So, here, because when you are adding you are getting 2, 2 is not required because we are equating dimensionally only. So, this has got dimensional this, left hand side also has got the same dimension. So, you can write left hand side is equal to right hand side. It means this given relation is correct dimensionally. So, just we have written the dimensional formula on the both the sides of the equation and equated. If you are getting any number or any other quantities which are dimensionless, that cannot be solved or that cannot be checked here. So, now take another example of the checking of accuracy of given relation. Example 2 we can take. Suppose you have got v is equal to under root of gm upon r. This is the orbital velocity of a satellite, where v is orbital speed, capital G is universal gravitational constant, capital M is mass of the earth, r is the radius of the orbit. You have to check whether the given relation is correct or wrong using dimensional equations. First we take here left hand side. Here you can write v, dimensional formula of v is m raised to power 0 L raised to power 1, that is t raised to power minus 1. If you take right hand side, you can write under root of gm upon r is equal to under root of m minus 1 L cube t raised to power minus 2. Here is m divided by L. You can get the dimensional formula for capital G, already we have done. Solve it, you will be getting minus 1 and m raised to power 1, that will become m raised to power 0, L raised to power 3 and here L raised to power 1, it will go up and minus, that is L square and t raised to power minus 2. If you take a square root of this, you will be getting m0 L and t raised to power minus 1. So, now see, left hand side is this, right hand side is this, thus you can write left hand side is equal to right hand side. That is, both the sides of the given relations are dimensionally correct, it means the given relation is correct. Now, second application is conversion of one system of unit into another system of unit. So, second application we can write conversion of one system of unit into another system of units. See here, you know it, when the quantity is changed from one system into another, its magnitude does not change. So, we can write basically Q is equal to N1 U1 is equal to N2 U2. N1 is the numerical value when the unit is U1 and N2 is the numerical value when the unit is U2. Now, we can also write N1 M1 raised to power A, L1 raised to power B, T1 raised to power C. These are this is the dimensional formula, the dimensions of the different quantities in the one system of unit. A, B, C are unknown right now here. Now, we can write here A2, M2 raised to power A, L2 raised to power B and T2 raised to power C. Suppose you have to get N2, N2 is equal to N1. We can write M1 upon M2 raised to power A, L1 upon L2 raised to power B and T1 upon T2 raised to power C. See here, dimensions I have taken A, B, C. Right now it does not have any particular value, but as you know the quantity, in the quantities, given quantity A, B and C are known to us. So, just by putting the values of A, B and C, putting the values in one system and then putting the values in second system. If you want to convert in the second system into the first system or the first system into second system, you convert according to that. M1 has to convert it into the second system. So, convert, suppose mass is given in initially kg and M1 is in kg, M2 is in grams. Now, if you want to convert kg into grams, so convert kg into grams. Similarly, here if L1 is given in meter, L2 is given in centimeter, now you want to convert into centimeter, so convert L1 into centimeter. Similarly, with the time. So, now let us take one example of this. Now, see here, you have to convert here. This is the example of the second uses of dimensional equation, that is a conversion of one system of unit into another system. Question is, convert 1 Newton force into dyne, that is a CGS system. You know, here force, dimensional equation for force is m raised to power 1, L raised to power 1, T raised to power minus 2, here 1 and 1. So, we can write A is equal to 1, B is equal to 1 and C is equal to minus 2. Initially, we assumed A, B and C. Now, in this is 1 Newton is SI unit. You can write 1 Newton is equal to 1 kg meter per second square and 1 dyne is equal to, you can write 1 gram centimeter per second square. So, what we can do here, that means M1 is equal to 1 kg, M2 is equal to 1 gram, L1 is equal to 1 meter, L2 is equal to 1 centimeter, T1 is equal to 1 second and T2 is equal to 1 second. In both the cases, time is in second. Apply the formula, N2 is equal to, N1 is given to you, numerical value is given to you 1 because it was 1 Newton. You can write 1 into 1 kg divided by 1 gram raised to power 1, 1 meter divided by 1 centimeter raised to power 1, 1 second divided by 1 second raised to power minus 2. Now, we have to convert SI unit, that is MKS unit, into the CGS. It means kg has to be converted into grams, meter has to convert it into centimeters. So, you write it here 1000 gram divided by 1 gram into 100 centimeter divided by 1 centimeter. This is only 1 s upon 1 s raised to power minus 2. When you solve it, you will be getting 1000 and 2, that is 10 raised to power 5 gram centimeter per second square, that is equal to 10 raised to power 5 dyne. So, you have converted one system of into in another. It means 1 Newton is equal to, we have got 10 raised to power 5 dyne. That is the CGS unit of force. Now, see, this is the third application of dimensional equations. First, this is a derivation of formulae. You have to derive the formula. See, take the example, derive an expression for time period t of a simple pendulum which may depend upon mass of the bob m, length of pendulum L and acceleration due to gravity g. We know time period may depend upon mass, length and g. So, we have to derive formula for time period. So, see how do we start here. First, let T is proportional to m raised to power a, L raised to power b and g raised to power c. We do not know the dimensions a, b and c. So, I have assumed a, b and c. We can write T is equal to k m raised to power a, L raised to power b and g raised to power c. K is any proportionality constant over here. We can write dimensional formula for all m0, L0 and t raised to power 140. For m we can write m raised to power a, for length we can write just L raised to power a. For g, this is acceleration due to gravity, which has got the same dimensional formula as acceleration. So, we can write Lt raised to power minus 2 raised to power c. We can solve it here. m0 L0 T1 is equal to m raised to power a here and L raised to power a here, L raised to power c here. So, we can write here, sorry, this is L raised to power b, L raised to power b here, L raised to power c here. So, we can write L raised to power b plus c and t raised to power minus 2c. Bases are same, so x power can be added. Now, see both the side, apply the principle of homogeneity. In this case, if the bases are same, their exponent are equal. So, here m raised to power a, here m raised to power 0. So, we can write a is equal to 0. Here L raised to power b plus c, here L raised to power 0. So, we can write b plus c equal to 0. Here t raised to power minus 2c, t raised to power 1. So, we can write minus 2c is equal to 1. So, c is equal to minus 1 by 2. Replace the value of c. So, b minus 1 by 2 is equal to 0. So, b is equal to 1 by 2. So, you have got the value of a, you have got the value of b and c. Now, put all these values, this and this in this relation. What will you be getting? T is equal to, k is any proportionality constant we do not know. So, we write k m raised to power 0, L raised to power 1 by 2 and g raised to power minus 1 by 2. And this formula can be written k, m raised to power 0 is 1. So, we can write under root of L upon g. So, this is actual formula which we need to derive. So, see here in the question it was given to you time period depends on L and G, but their dimensions was not given. That means it was may depend on, right. So, see the time period does not depend on mass. So, the m raised to power 0 has come in the solution, and where L and G are the factors which are affecting the time period. So, they have come according to their dimensions. So, third application can be used to derive any relation, but this relation should not include any constant which is dimensionless, because you cannot derive. If you are also getting in this for any formula like anything like a sin theta, cos theta, even you are getting 1, 2, 3, e you are getting, that is exponent and exponential, or you are getting pi, if these things are coming into the formula, you cannot derive by using dimensional equations. So, these are the two limitations. And also one limitation is here, suppose you are getting more than 3 quantities, the given quantity may depend on the more than 3 quantities for 5, then also it cannot be derived. So, there are certain limitations of the dimensional equations or dimensional analysis. Let us take another example. Now, see in this question, this example is also actually based on the third application, derivation of formula. Using the method of dimensions, derive expression for the rate of flow of liquid, that is V. Rate of flow of liquid is the volume of liquid flowing per second of liquid through a pipe of radius r under pressure gradient P upon L, and also given that rate of flow of liquid depend on coefficient of viscosity eta. Now, see here, we can write let V is proportional to r raised to power a, P upon L, that is a pressure gradient raised to power b, and eta raised to power c. We can put a constant. So, V is equal to k r raised to power a, P upon L raised to power B eta raised to power C. Put the dimensional formula of all. V, that is the rate of flow of liquid, volume of the liquid flowing per second, that is m0 L cube T raised to power minus 1 is equal to K, R is just L raised to power A, P pressure gradient you can write mL minus 1 T raised to power minus 2 divided by L raised to power B, and eta can be written mL minus 1 T minus 1 raised to power C. If you solve it here, you will be getting m raised to power 0 L cube T raised to power minus 1 is equal to K. Here see m raised to power B and m raised to power C. So, first we can write m raised to power B plus C. Here L raised to power A. Here L raised to power here L and minus 1 it will go up. So, the minus 2 and into B. So, a minus 2B and L raised to power minus C here, and T raised to power minus 2B and minus C. Now, bases are same, so their exponent will be equal. So, we can write here B plus C is equal to 0, A minus 2B minus C is equal to 3, and minus 2B minus C is equal to minus 1. So, you have got three relation. One is B plus C 0, one is this relation, and one is this relation. By solving these relations, you have to get the value of A, B and C. You start from here, you are getting B plus C equal to 0, so you can write B is equal to minus C. Now, we can go for here. Now, in this case minus 2B, in place of minus C you are writing here the B. So, you can take here plus B is equal to minus 1. So, you can get here minus B is equal to minus 1. So, B is equal to 1. If you have got B is equal to 1, C you have got already, then the C B equal to 1, then C will be is equal to minus 1. Just you need now the value of A. A will be here, see here, A minus, in place of B you will be writing 1, to minus 2 and minus 1, that is plus 1 is equal to 3. So, here we have written A minus 2 plus 1 is equal to 3. So, minus 2 plus 1, that is equal to, you will be getting A is equal to 4. So, you have got all the values, A is equal to 4, C equal to minus 1 and B is equal to 1. Now, replace all these values in this relation. So, you will be getting V is equal to K, A you have got 4, so R raised to power 4, P upon L you have got B 1 and eta raised to power minus 1. So, you can write V is equal to K, P R raised to power 4, here eta L. But see here, actually the constant in actual formula K is equal to pi upon 8. But as I have told you, if in any equation there is a dimensionless constant, then we cannot derive them by using dimensional equations. So, actual formula for this is pi upon 8 P R raised to power 4 upon 8 eta L, which is here K. So, I have written just K because we do not know. Now, see next example, where P is equal to B minus x square upon 80, where P is power, T is time, x is distance. You have to find dimensions of A and B. Now, see this example actually based on the fact that only like quantities can be added or subtracted. It means two quantities having same dimensions can be added or subtracted. See here example, here B minus x square, here B minus x square, see x is a distance. So, obviously x square can be written here L square. Now, x is subtracted from B. So, obviously B and x square have the same dimensions. So, we can write B is equal to L square. Now, we can go for the A. We know it P is equal to B minus x square divided by AT. We have to get A. So, we can write A is equal to B minus x square by T into P power. B minus x square's dimension is L square. So, we can write A is equal to L square divided by, now time we can write T. Power can be written work done upon time. You know the formula of this dimensional formula of work and time you can calculate. So, that will be coming round m L square T raised to power minus 3. This is the dimensional formula of power. If you take this L square will get cancelled. So, you can write m raised to power minus 1, m will go up. Now, here m will go up and t raised to power minus 3, t raised to power 1, that is here minus 3 plus 1, that is minus 2, and t will be going up. So, it will become here L raised to power 0 and t square. So, this is the dimensional formula of A. So, by this way you can get the dimensional formula of A and B. The main concept is here only two similar quantities can be added or subtracted. Now, see this example, V is equal to A plus Bt plus C upon D plus T, where V is velocity, T is time. Find dimensions of A, B, C and D. Now, see here left hand side equal to right hand side dimensionally. So, whatever is the dimensional formula of V, each term on the right hand side will have the same dimensional formula, because we know the concept here only like quantities can be added or subtracted. So, obviously, so here dimensional formula of A is Lt raised to power minus 1, because V is velocity here. Similarly, dimensional formula of Bt is equal to Lt raised to power minus 1. So, B is equal to Lt raised to power minus 1 divided by T, that is Lt raised to power minus 2. Now, come to this term C upon D plus T. D and T are added together. So, obviously, D has the same dimensional formula as T has. So, C upon D plus T is equal to dimensionally, that will be equal to Lt raised to power minus 1. We have to get C. So, we can write here C upon T is equal to Lt raised to power minus 1, this is T, it will be going this, so C is equal to L only. So, you have got the dimensional formula of A, B, C and